Hello, welcome to this Horner Tech Tip video where we'll be demonstrating how to use the Horner OCS data logging functionality. The Horner OCS has a removable media such as a micro SD or a thumb drive, and it can actually write data from the process or from the internal memory to that removable media in CSV format. So you can grab that media out and read the data directly with your Microsoft Excel. That's super handy and great troubleshooting aid. So in order to demonstrate data logging, we'll need some data. So I created a really quick logic set here that just kind of simulates a tank pump situation. So if we turn on, go to debug here and turn on the data watch, which is just a feature that demonstrates or displays internal registers in the Horner PLC all in one place. You can have the memory from various areas in your logic displayed in one place. So the top value here is the simulated tank level. So that tank is going to go up to 60%, and then you'll see this pump, which is line 2. You can see the tag names here, start, and that tank level is going to go ahead and pump down to 40%. The pump's going to turn off, tank's going to go back up. So that's just kind of a cyclic kind of process we have running here to kind of demonstrate that the actual live real-time data is getting captured. So just to go into the data watch configuration, we can just go in the home and open the data logging here. There's also a data logging on the side that you can open, but we'll just click it up here and enable the data logging is the first step, top of the configuration. Then here's where you'll create data logging groups. You can have various groups. You can log the same data, different frequencies, different trigger points, which we'll get into right away. One thing you do have to configure is the group attributes here. The top attribute is a status register, which will display fault data or any issues you're having with your data logging, and you can use it to troubleshoot. The second one is a discrete bit, which is just the one bit which will enable all of the group data logging. The top one is two 16-bit registers. You can see 16-bit times 2 here, and that's got quite a bit of data for analysis. But this one, again, is just to stop all of the groups that we're going to create. Normally, I actually don't use this discrete one. I'll just use any bit that's always on, such as in Horner, always underscore on or ALW underscore on. And in the register type, it's an S7. But for today, I've just used an M6 in there for demonstrations, kind of show up that it does work there. So we'll get out of here and we'll start creating our data logging groups. So each group, like I said, can have different sorts of data and that kind of thing. So since we're using a tank pump situation here, or a simulator, we'll call this first group tank pump. And the significance of this group, other than just knowing what this group has inside of it, is it actually, remember I said that it's going to write CSV files to the removable media. Well, they'll be in folders, and the folders that files will be stored in will have the same name as these groups. So it's kind of handy to keep these intuitive for your analysis later. So there's the group. So let's start adding variables. You can have any type of memory you want here. We're going to start with a real, which is 101R, just pre-configured bit of memory that I've put tag names in earlier. By now you know how to tag your addressing and stuff like that at the data logging level. So this is just a register that we picked to put the tag level in. It's a real and it's tagged there. So we just say okay, and there we're going to be logging that as soon as we turn that global M6 on. So we probably want to know if the pump's running or not. So that would be a Boolean or a single bit register, and the pump we have pre-configured in that simulation is 3M. So again, you can pick anything out of your data that's important to you. So there's the pump running bit there, and then there's a pump fault bit as well that we'd want to know, when the pump's faulted. So when we're having troubles, so we'll add that. That's going to be 5M. And again, that is a single bit Boolean type of memory. So there's our pump fault. So there's a first group. Now there's group attributes here. Remember, we configured the global attributes. So there's group attributes as well that are similar, and they have also two 16-bit status registers. Remember, we used register 9001 on the first. So Since it's 2, that used up 9001, 9002. So here we'll go ahead and use 9003 as our status register. And these group registers will contain diagnostics specific to the group. The global, which we configured earlier, will have the global. And if you are having any issues with your Horner data logging functioning, just go to the help up here and then type in data logging, and you'll get kind of a step-by-step of what we're doing here, as well as these are tables of what the specific fault codes might mean. For instance, if the medias are ready for data logging, there will be a 0 in it. If it's not formatted, there will be a 1, and so on. And then that's the global, and down here the group. Various codes that you'll get in that status register if you're having issues there. So just helpful piece of information if you do have trouble, but typically this works pretty well. So here is the data logging interval. So this first type of data log we're going to set up is just one that we just want to log, say every hour, every day, every whatever your process dictates. In our simulator here, we're going to want a few samples in this short video. So let's just go 10 seconds. That's probably way too fast for most processes for your timed data logging, but we'll go ahead and use 10 seconds for, like I said, demonstration purposes there. So that data log's done. And so there's another type of data log we'd like to discuss. That's a timed one. And there's also a triggered type of data log. So let's go ahead and add another group. And this will be only triggered when the pump is failed. So let's call this pump fail. There we go. There's our pump fail group. Remember, that's going to show up as your folder name. So we can use the very same registers in this case. We could use any registers we want. In this case, we just want to use the same ones because our simulator's a bit limited for data. So we'll go ahead again and say the tank level we want to watch. And we want to know when our pump's running again, 3M that was. And again, that's a single Boolean. And same as the other one, we want a 5M to know when our pump's faulted there. So it's just going to give us a status when the pump's faulted. And so remember, this is a triggered data log we're trying to build. We got our variables. If we click on the two groups are identical, same registers. Here's where they'll start to get different. So we're going to go into the group attributes again. Next one available, of course, is 2 registers up, or 9005R. And here's where they kind of get a different, like I said. So we're going to go to triggered only. So in this case, we use a discrete triggered bit, and it's just, again, 1 bit, and it will trigger and start this data log when that bit goes high. And it will only log 1 line into your CSV file when it goes high. So it's going to be a pretty short data log if you just trigger it once. But each time this goes high, you get 1 line. So you can trigger this bit with a fault or a problem or any kind of occurrence in your program. But we also have ways to make it also, log more than just 1 point. So let's just say, okay, our data logs are done. And our pump is running away. Things are working well. And if we go into debug here, and we can watch this logic work as well. Debug will just highlight the logic that's on with red, and you can see that's the tank level going up and down and that kind of thing. So you can see I've got my pump fault here, and I've got register M7. Remember, that's the pump fault trigger. So when the pump faults, I just put a tsec bit, which flashes every second. So when the pump faults, this is actually going to write data every second, every time that thing turns on. So let's go ahead and turn on our M6. Remember, that was our, so that's just typing a 1 in there. That was our global data logging. So now the data is getting logged to the processor, and it's getting logged every 10 seconds. Remember, we have that timed one, which is just the normal operating one. And every 10 seconds, it's getting logged. So we should have captured maybe 2, maybe 3 since I've hit that on there. Here's our pump fault. You can see our pump is running. So the pump is off now. Tank filling up again. The pump is going to start again. And so if we get a fault, so there's the pump running. If we get a fault, while the pump's running. There we go. The pump is going to turn off, and this tank level, which is being filled by the process external to the tank, is just going to keep going up. In a real process, obviously, we'd have shutdowns, alarms, and protection against this tank overflowing. But for this simulation, we're just going to let it go. Of course, 100% is as full as it can get. Now, hopefully it's water or something that's not too nasty and it's just spilling out on the floor or whatever. But like I said, in a normal process, we would have alarms and shutdowns and stuff. But since we turned down that fault bit, see, that's high, this is high, and then our fault trigger is flashing every second. So that should be giving us one data log each second. So let's go ahead and pull the memory out of the processor there, and we'll just put it into the PC here and pull up the file manager there and see what we got. So here's our removable media, and the typical timed log is the tank pump. Remember, we named that group tank pump, so that's our folder name. And so let's open that up and see what we got for data in the tank pump. So remember, we set the frequency for that log at 10 seconds. So we got 1754, or sorry, 45, 55, and so on there. We could see the pump was running. The tag names that you use on your data end up being the headers on your columns there. So it's super intuitive. You can just open it up and understand it, So it is important to, use good tag names on your data so that you can understand it here. So here we have 1754-55 date, of course, as well. If we expand that out, you can see the whole date. And the tank level, the pump is running, tank level is going down, and pump is starting, tank level going up, and so forth. And when we got a fault, right here, the pump fault row here, the tank level just continued to go up to 100%. And notice we only have 2 samples of that whole occurrence from that fault to till we're full. So let's go back in the USB and let's look at the pump fail log here and see how that differs from the timed routine. So here's our fail, and we know that it was only going to start when the failure occurred. So the failure occurred down here. So here's the pump fail, which is every second now. Only when the pump is faulting, like this row here, will there be data collected, because that's the only time we're interested in when we have a problem. So there's the 36 second, 37 second, 38 second. So you can see it's capturing data every second now. And the time from when the pump was faulted till we were at 100%, looks like we had about 17 samples. So a higher resolution, much better for troubleshooting and so forth. On the typical time data log, what do we have here? Pump faulted, 2 samples. That makes sense. So it's every 10 seconds, and this is every second. So anyways, that's kind of a quick video on how you can use your Horner processor to capture data, store it on your flash, take it out, analyze it, manipulate it as you need, graph it, trend it in your Microsoft Excel. Okay, thanks for watching.